Hello and welcome to our webinar today. Today we will be discussing the topic dynamic feed-in management with Fronius inverters. And joining me today for this webinar is my colleague Cyprian Okolo, the technical sales advisor for Western Africa based in Lagos, Nigeria. And myself, David Mwangi, I'm the technical sales advisor for the Eastern African region. I'm based in Nairobi, Kenya. In our agenda today, we want to discuss the Fronius smart meter and the use in feed-in limitation. We will also talk about some new features that are coming up for all Fronius inverters. We have, for example, the asymmetric generation feature. We will give you what is the possibility when you're configuring multiple inverter systems. And that means also with different inverter models. The new system power control feature as well, which will be brought together with the asymmetric generation soon. Installation and commissioning, what you need to know, dynamic feed-in limitation, commissioning demo, that will be done by Cyprian, and then at the end of the presentation, we'll give you some further information. So let's just do a quick repeat on the Fronius smart meters. I think our regular installers are familiar with these smart meters, but they are important for our topic today. So the Fronius smart meter, of course, is a bidirectional meter. It measures consumption and how much is being fed into the grid. It's also able to show you how much, therefore, is the balance of energy supply in the setup. So therefore, the smart meter becomes an important base for Fronius SolarWeb. So SolarWeb is the Fronius monitoring platform. And therefore, you get here the possibility for analysis as well as visualization of consumption data, and becomes a key element when you're doing your monitoring as far as overall site analysis or any advice you might want to offer to your customers after the system has been installed. In terms of the available smart meters, we have about 4 recently introduced smart meters. The touch screen, which we refer to as the TS smart meter, available in single phase at 100 amps. So this is offering communication via Modbus RTU. We have a 3-phase smart meter available at 65 amps. So this is also touch screen, offering communication through Modbus RTU as well. Then you have the commercial smart meter, 5 kilo amp, offering communication through Modbus RTU as well. And then most recently, we do have now also the IP 5 kilo amp. So the smart meter IP 5 kilo amp. So this is also a 3-phase smart meter, has the possibility to offer communication via Modbus RTU as well as Modbus TCP. This is for both LAN and Wi-Fi. In terms of where these smart meters can be used, we have the application of the Fronius smart meter single phase 100 amps for residential kind of applications, similar to the 3-phase 65 amp smart meter. This is something that is engineered for residential application. Then when it comes to commercial systems, we have the 3-phase 5 kilo amp smart meter. And this is where most likely you'd have incoming feeder cables bigger than 16 millimeter square. And therefore, you would require to connect also current transducers, typically with about 5 amps secondary current. We also have the use of the smart meter IP 5 kilo amp in commercial and industrial applications, for example. This is also very nice when you have loads with very long distances from the inverter to the measuring point or to the distribution board. And therefore, you can achieve communication, like we mentioned, via Wi-Fi and LAN instead of just Modbus RTU. For this smart meter, also a CT is required, and the secondary current here will be about 333 millivolts. So when it comes to the application of the smart meters, we typically have a smart meter installed at the feeding point. And in terms of knowing whether the smart meter is installed at the feeding point, it's typical to have the inverter power on the load side of the smart meter. And therefore, that description would tell you that your smart meter is connected at the feeding point when you are doing your configuration. Another description would mean that your smart meter is just next to the utility meter. So if you do that kind of connection, that it means that your smart meter is connected at the feeding point. So for this kind of connection, this smart meter would give the inverter surplus data in terms of what the power flows or the energy flows happening at the feeding point. And a primary smart meter, in this case at the feeding point, would be required, for example, for all battery solutions and load or feeding management applications that you might want to do. Another use of the Fronius smart meter is in the case that you want to integrate also additional smart meters other than just the primary smart meter. So you could have consumption smart meters. So if you want to measure consumption by an external load or a very specific load that you have in your setup, then you can integrate a further smart meter, and this then would be connected along the consumption path. And the connection path basically means that inverter power will be connected to the grid side of the smart meter, and therefore this will be the description or the positioning of a smart meter along the consumption path. So you could have maximum in this case about 4 smart meters. So you have 1 primary smart meter and a possibility also to have an additional 3 secondary smart meters. What is important is in terms of how you do the connection of the smart meters, regardless of how many they are. So you do need to activate the terminal resistance for the Modbus communication. So this requires that the first and the last devices on that Modbus communication loop are terminated with this terminal resistance. So if you're talking about the newer inverters with the pilot communication card, we have 2 Modbus channels, and you can see that you can put the dip switch in the on or off position. So depending on which channel then you're using, you have to activate the terminal resistance by putting it in the on position. All the other smart meters or Modbus devices in between the first and the last one do not require terminal resistance, and therefore that is not something that should be activated. It's also possible to use a smart meter for measuring, for example, if you have done a setup or integration of a third-party inverter into a Fronius powered system, or you have integrated a Fronius solution into an existing third-party inverter solution, then you can position a smart meter next to the third-party inverter, for example, to be able to measure what is the power generation of this third-party inverter. So the same kind of connection will be done. So you'd have your primary smart meter, and this would be like just a typical energy meter to show you how much this inverter is generating. Then you have the Modbus connection from this smart meter to the primary smart meter, and then on to the inverter for communication of this data. A typical example and use case for the smart meter IP will be for installations whereby, like I mentioned before, the feeder cable to the inverter, from the inverter to the distribution point, is very long. Typically for Modbus RTU, we say that the cable distance on Modbus communication should be a maximum of 300 meters. Sometimes it's quite complex because of the layout, how to really bring this cable from the inverter to the smart meter. And therefore, if these kind of limitations or barriers are there, you have another solution whereby you could use the Fronius smart meter IP, And it makes it very easy because you do not have to do the communication cabling directly from the smart meter the way you do it for Modbus RTU. In this case, if you have a strong Wi-Fi signal close to the smart meter, you could use the TCP communication to then bring the data from the smart meter into the router, for example. Then this same router will be in the same network with the data manager or the pilot card in the inverter, and therefore you will be able to transmit your data from the smart meter to the inverter in this manner. Another important aspect that we want to highlight on today is asymmetric generation. What we have known in the past is that all Fronius inverters have symmetric output on the AC side. Therefore, it means that, for example, if you have a 15 kilowatt inverter, each of the phases would give you maximum 5 kilowatt. However, this is not always the best generation, because as we know, some premises or some loads or consumption in some premises is not balanced at all. And therefore, it might be helpful that you have the possibility to generate more on one phase compared to the rest of the two. For example, if you have a 15 kilowatt inverter, it might be useful to have, for example, a 5 kilowatt on L2, and then L3 and L2 are producing something like 3 or 2 kilowatts, depending on how much consumption is on at that particular moment. So this feature is going to come up soon with the new software update that is going to be released soon. So no hardware adaptations are necessary to achieve this kind of configuration within the inverter. So as you can see here, once we do get the software version 1.31, then this would mean that the pilot-based, especially the pilot-based inverters, we are talking about here the Gen 24, eventually also the Tauro inverters, and also the new inverters that are going to be introduced later on, the Vato series of inverters, will have this possibility for asymmetric production. And this asymmetric production will be at the scale of about 33% maximum asymmetry. So it means that if you compare phase to phase, then it has to be 33% of what that particular phase is capable of producing as maximum. And therefore, if you take away the 33%, then that would give you how much asymmetry you could have on each of the phases. Feed-in limitation. What to do if you have multiple inverters in one setup? This is a very common question, because sometimes you have old installations with snap inverters, and you might want to integrate the newer inverter, which could be the Gen 24 or the Tauro inverter. As we know, the Gen 24 and the Tauro inverters, due to the architecture of the communication inside, do not allow inverter to inverter communication like we know of the snap inverters. So in this case, it means you need a different solution, and therefore we have a solution that ensures that you have only one master inverter that gets dynamic power reduction or limitation, and then from that master inverter, the other inverters in that network are able to get their limitation effects as well. So in this case, you are able to do dynamic feed-in limitation, just like we know for systems that have multiple snap inverters. But in this case, if you have a mix of, let's say, snap inverters, Gen 24 inverters, or Tauro inverters, then you do require a slightly different kind of solution. In a typical feed-in limitation, as we know it, we have an example here of a 24 kilowatt peak PV system with two Gen 24 plus Gen 24 devices, each is 10 kilowatt. So that makes it, making it 20 kilowatt AC power. And you have a feed-in limitation of about 5 kilowatt. So the limitation in this case would be done to the master Gen 24 only. So this is the only possibility. And then the slave inverter would remain at the same limitation level. So in this case, feed-in power will be at 10 kilowatts and use the second inverter with a maximum 5 kilowatt possibility going to the grid. So if we do require here the limitation, we are able to limit the first master inverter, and then the next inverter is producing the maximum output that is possible. So just a moment. At this point, let me hand over to Cyprian to be able to take over and do the next part of the presentation. So Cyprian.
Yes, indeed. Thanks for that, David, for your presentation. Yes, just a moment so that I can take over presentation rights. Okay, so I want to believe that my screen is showing and I can be heard loud and clear. So yeah, like David mentioned, yes, so we are now introducing the system power control, which is basically what we're going to use to implement the dynamic feed-in limitation. So this is basically a new algorithm, I would say, because it's not a device, and it's a very welcome development coming from Fronius. So in order to give us context of what we're talking about, yeah, why don't we do a bit of a illustration to really drive home the message. So assuming we have a collection of inverters, as you can see, and they're all required to communicate effectively so that a proper feed-in protocol is observed in relation to the grid. This is basically not possible if there isn't, if all these inverters are not synchronized in the system communication-wise, so that the proper or appropriate feed-in protocol is obeyed. So in order to make this clear, I would want to relate it to, say, an orchestra or a choir gathering per se. So the orchestra wouldn't actually perform properly if there isn't a choir master or a conductor per se. Yeah, so with a conductor, you are short of getting the right output, the right symphony from the system. So that is basically what is happening, or what is going to be implemented using the system power control. So therefore, we need a master, or more or less a choir master, which in this case is going to be a pilot device. So it could be Gen 24 plus, a Gen 24 or a Tauro inverter, as we're going to see in different scenarios in subsequent slides. So with the pilot based device or inverter, we will now be able to achieve power dynamic power control, of course, using the system power control algorithm. Yeah, so going forward, of course, as we notice from the illustration here, the choir master basically needs something of a wand to be able to conduct the gathering or the orchestra. So that would come in the shape of a smart meter. So basically, the smart meter is the communication channel through which dynamic power control can be achieved. I hope I've done justice using this illustration to explain what dynamic power control or system power control basically means. So going forward, this is what used to be. If it were in the case of the use of a Gen 24 in a mix with snap inverters in the system, just like David has earlier explained in his slides presented, it would warrant us making use of multiple smart meters. So we'd have a primary smart meter connected at the grid feeding point, and then you now have branch inverters or branch smart meters or smart meters at the consumption part, so that communication and feeding would be able to be implemented appropriately. So that was for a mix of Gen 24 and SnapMeter. For the Tauros, yeah, only a plant controller was possible to make use of to achieve feeding limitation, as you can see. Okay, so and of course, implementing a plant controller would imply additional costs, and this usually comes in the range of €1,000. That kind of made system more expensive, or kind of added an additional cost to the system. So coming from Fronius, we've been able to introduce, or we will be introducing the SPC, that is the system power control. And with it, amazingly enough, there wouldn't be any need to add hardware. Okay, so there's no hardware needed. It's basically an algorithm that is going to be installed in the system during the upgrade, during the software upgrade. So once that is done, all you need is for a pilot-based device. So it could be a Gen 24 plus inverter, or a Gen 24 inverter, or a tower inverter. So I'm going to be more specific here. So in the case where you have battery backup needed in the system, that of course entails that we're going to be needing a Gen 24 plus inverter, hybrid inverter, battery connectable. So that Gen 24 plus inverter would become the master compulsorily for the system. Okay, good. So in any case where a hybrid inverter is not needed, then the Gen 24 or Tauro must be the master in the system. I hope that explains it. Good. So let's have a broader look at it. So let's, yeah. So using the illustration in the previous slide, this is basically a simplification of what I have mentioned earlier. So with the help of a switch, a router switch, you can now interconnect all the inverters in the star topology, and then the master now is the main instrument or device that controls whatever output is coming from the other inverters via this star topology communication line. So for this, it means that we can actually dynamically implement feeding limitation for up to 20 inverters in a system. So you could have multiple snap inverters also, but then because of design, it is recommended that only 5 inverters, that is snap inverters, should be connected per solar net ring. By this, we mean that, of course, for all those who are conversant with this, snap inverters come in light and full versions. Light versions are data manager less inverters, while the full versions are the inverters with data managers. And to implement the solar net ring, just like the name implies, it's a ring topology. So meaning that the inverters are connected communication-wise via a ring topology. So in that case, there's only one master that is needed. So all other inverters in that solar net ring are all slaves. So you can more or less say you have a submaster. You can have a submaster in a system that's containing a solar net ring. But then we now have the main master per se, that is the pilot-based device. Good. So having said that, you can also have multiple Gen 24 Tauros and then Gen 24 Plus with the battery connection. And all communications are via Modbus TCP. And good enough, only one smart meter is needed. That is basically one smart meter connected to the feeding point. And as David also mentioned, it's coming soon. So this would be available via software upgrade. No hardware is needed. The software version is version 1.31 and will be coming soon, somewhere around Q2, not exceeding. And hopefully when it comes, you will all be appropriately informed. So let's keep our fingers crossed for this. Yeah, so like I earlier mentioned, just wanted to present us with 3 basic scenarios where you could have this implemented, dynamic feeding limitation. So in combination of Gen 24 inverters with Gen 24 plus inverter, as you can see. So in the backup mode, only the Gen 24 plus is recommended to be the master, compulsorily that is. So all other Gen 24 inverters are the slaves, as you can see. So, and as earlier mentioned, you can have up to 20 devices. So you can have one Gen 24 plus and 19 other Gen 24 inverters, basically speaking. So in another scenario, you could have a mixture of the Gen 24 and snap inverter. So you could either have the Gen 24 as the master with the other sub solar net rings per se with their respective sub matters. Since we've already mentioned that a maximum of 5 snap inverters should be connected in a ring. So you could have one master and then up to 4 slaves per solar net ring. So as earlier mentioned, you can have it the master to be, or the main master in this case, to be a Gen 24 inverter or a Gen 24 plus inverter with a battery connected. So in the case of that is scenario 3, connection with towers, yeah, it can be this way. So you'd have all the towers connected to the switch, and then of course via LAN or wireless LAN connected to the master of the particular system, and then that is now connected to the smart meter, and then of course to the grid. So what basically happens is that, as I've mentioned in the illustration, so the master basically conducts what comes out of the system in the appropriate and configured manner in relation to the grid protocol. Good. And mention must be made here because we've mentioned that up to 20 inverters are recommended for each system. Yeah, this is so because communication is key. And since that is the case, the reaction time is also key. So you'd want your system to react in the fastest possible time to ensure that there is no breach in terms of the system feeding control protocol. So if there is any need to go beyond 20 inverters per system, then that would imply us making use of a third-party plant controllers. But we believe that 20 is a decent number. But then we're just making it clear here as a information going out to everyone. If there is any need to go beyond 20, because of the intention of having communication and reaction time top-notch, you might want to implement the use of a third-party plant controller. So let's have a brief look at the installation and commissioning process. So I am just going to take you through what it entails, and then hopefully be able to take you through a demo for you to actually see how this is implemented. So assuming we're already in the web UI platform of the Gen 24 inverter and have already gone through the necessary steps and are at the export limitation point, as you can see. So next up is to enter the setting or the mode of the feeding limitation. It usually comes in 3 modes. It's either comes in the off mode, limit per phase, or limit entire system. So it is recommended that you click on or select limit entire system. And once you select that, you can now go ahead and enter the total DC power of the system. That is the entire power of the system. So ensure that you impute it in watts. And once you do that, also you need to activate export limiting control soft limit. If you look closely, you would see that we have what we call hard limit. So it is recommended that you choose soft limit because soft limit doesn't shut down the entire system. What it does is to, in a case whereby there is a transient spike in power, which might adversely affect the feeding limitation process. This would, of course, bring it under control without necessarily shutting down the entire system, which the hard limit does. So going forward, here is where you now enter the maximum feeding power. That is the power over which, yeah, I think that's it. Yeah, the power that must not be exceeded to be fed into the grid, basically. Yeah, so once you enter that, via the communication with the master inverter, it will ensure that whatever the entire system does, the feeding into the grid would not exceed this figure, basically speaking. Now, very importantly, it is recommended that you can turn on the switch, that is to reduce the inverter power to 0 if meter connection has been lost. Like I said, communication is key. So once there is a breach in communication between the master inverter and the meter, then your system stands, the entire system stands at the risk. Because if the system is overproducing, then that means you might end up feeding more than necessary into the grid, or more than is appropriated into the grid, and that would cost the system owner a penalty. So in order to avoid that, you can trigger the switch to reduce the power of the system to 0 if meter connection has been lost. And of course, if it is restored, the system comes back to status quo. Good. So having done or gone through this setting, you can now go ahead and add the other inverters. So you're expected to add all the inverters, okay? So once you're at this stage, you're going to see a prompt, a hyperlink that would enable you to add all the inverters. So once you're doing the additional process or the addition process, you're going to just have to enter the respective IP addresses of the inverter. And then for the submasters, as I would like to call it, because of the nature of solar net tree, you are only expected to add just the IP address of only the submasters per se. And then once you do that, you can now go ahead to the next step, which is checking your connection, ensuring that all added inverters are connected. So if there's any case of disconnection or inactivity, you have to go through your system connection, check your internet connection, also ensure that everything is in place. And I believe if everything is done correctly with all the conditions in the right order, you should have all your systems or all your inverters in the system is connected. Once that is done, you can now go ahead and it is possible for you to click or activate this option to allow for battery charging from other generators in the home network. So once you do that, you can now go ahead and save all this information, because if you don't save it, it would not be actuated. That's it. So once that is done, you can now go ahead and add all inverters on platform, that is SolarWeb, where you can easily monitor and view your systems, as can be seen in this case. Good. I believe that wasn't too stressful. Yeah, it's a step-by-step process. You just can't miss it. But then to put it in perspective, I would want to see if we can have a bit of a demo. So it's going to take a couple of seconds to activate because of the use of an intermediate VPN point. So, but then it will definitely pop up. So once it does, we would now go ahead and do a brief demo on how to do the commissioning. Yes, here we are. So of course, it would require you to impute the customer password during the initial commissioning process. So once that is done, you can now go ahead and enter your necessary, all the necessary details. Just to save time, because we need to be here at this network settings. So I have pre-filled this already. So we could just go ahead and fulfill all this so that we can get to the point where we need to activate the feeding. Good. So our target is to get to the export limitation. So like I said, I've pre-filled the other functions. I'm just going to click on next until I get to export limitation. So here we are. And if you remember from the screenshots we showed you, so all you need to do is to ensure that you enter limit for the entire system. As you can see, it comes, there are 3 modes, limit entire system, off mode, and then limit per phase. So they all function as they are titled. So this function limits per phase. This turns the mode off completely, and then this limits, it turns it on and limits for entire system. Good. So for this, for example, in this case, I have entered 10,000 watts, as you can see. That is, or that represents the total DC power for the entire system. And then I went ahead and activated limit, export limit control, soft limit, as I've earlier explained. And then you can now go ahead and enter the maximum permissible export power of the entire system. In this case, I have entered 5,000. So basically, it all depends on the installer and the communication with the grid. So of course, you would now be instructed on the particular or capacity of power to be injected into the grid. Then once you have that information, you can now enter it appropriately at this point. Yeah, like I mentioned also, it is important to also activate this just in case there's a breach in communication or loss of communication between the master inverter and the smart meter. That can actually present a risky situation that would might result to overfeeding into the grid. Good. So next is at this point, because this is simulation, actually, at this point, this is where you get the opportunity to add the other inverters. So once you add the other inverters, you would now be able to have them checked in the connection pane. So once that is done, then you're free to continue to register your product or all the inverters on SolarWeb. And then once that is done, you are, of course, entirely done with the commissioning of this particular special feature of dynamic feeding limitation. So like I earlier mentioned, it is a feature that is coming pretty soon, most possibly before the end of Q2. So once that is available, you can all upgrade your respective systems, and then you will now have the pleasure of implementing dynamic feeding limitation for your systems. Good. So in summary, just putting everything together, maximum of 20 inverters are allowed per system. Maximum, if you're implementing with solar netting, a maximum of 5 inverters, inclusive of the submaster, is recommended. Yeah, also remember to allow AC battery charging from other generators in the system or in the home network. Just one smart meter is needed for this to happen. So you don't have to implement branch smart meters, so which is an added advantage. And then ensure that you add all your devices on SolarWeb. So with this, I believe we've pretty much summarized what the system power control can do. Yeah, so with that, we've come to the end of today's webinar, hoping you all enjoyed the information we have for you today. And yeah, if you still in a loss or still need to get more information, of I understand that there was a loss in audio, so I'm just seeing that on my information pane. So I'll just go over this. So basically, you can get all the information you need as an installer, a system owner, both for residential and commercial. All you need to do is to click on the right buttons and it to take you to where you want to be. So just ensure that you click on solar energy when you come onto our homepage, because we have 3 business units: the welding, the charging, and the solar energy unit. And then once you're there, depending on your interests, if it's for homeowners, for business owners, but for this case, since this webinar is basically designed for installers and partners, so you can click on installers and partners. From there, it will take you to where you can have access to information about products and solutions, technical data, other information, service and support, downloads, and then of course, contact information. Good. So of course, you can access it via this link here, which is active. Just to inform you that recordings are available on our homepage, where you can have access to operating and installation instructions. On our YouTube channel, you can have access to all our how-to and installation videos. But more specifically, you can have access to all the webinars that we have produced so far on our Sub-Saharan Africa playlist via this link. So from this link, you can have access to all the webinars we've produced so far, including this one, which will be uploaded pretty soon after this webinar is concluded. So for more information regarding technical questions, training, sales, and after sales, please do well to contact us using the contact information showing on your screen. But if you want to get in touch with us directly, the technical sales advisors, please do so according to your respective technical sales advisor. Myself for the Western Africa region, Byron, who's not present for this presentation, but he is the technical sales advisor for the Southern Africa region. And then my colleague David, who's presenting here with me today, he is, of course, responsible for the Eastern Africa region. Great. So with that, we have come to the end of today's webinar, hoping that you enjoyed the content. And yeah, thanks for taking your time to attend. And until we come your way next time, do enjoy the rest of the day. Goodbye.